Okay, friends, day 2 for lesson 3.4. Still talking about sine and cosine function graphs. Yesterday we graphed sine curves. Today we're going to graph cosine functions. And just to review that vocabulary with you, a cosine function matches the measure of an angle in standard position with the x coordinate of the point on the unit circle. This point is where the terminal side of the angle intersects the unit circle. And the cosine curve is the graph of the cosine function. And we know the cosine of theta is that x coordinate of the point where the terminal ray intersects the side of the unit circle. Using the unit circle that we created in lesson 3.2, we want to complete the table of values for each angle measurement: 1, square root of 3 over 2, a half, 0, negative a half, negative radical 3 over 2, negative 1 at pi, negative radical 3 over 2 going into quadrant 3, negative 1 half, 0, 1 half, square root of 3 over 2, and finally 1. And you can see here we have a maximum value. We have a minimum when we're at pi. We have an intercept here at pi over 2 and at 3 pi over 2. And we have another maximum at 2 pi. So intervals of x where the y values are increasing would happen between pi and 2 pi inclusively. And intervals of x where the y values are decreasing would be from 0 to pi inclusively. We have a maximum, 2 different maximum points, one at 0, 1, and the other at 2 pi, 1. So minimum point would be at pi, negative 1. Here's the function. And labeling the 5 key points, you can see we're going to start with the maximum. So we've got a maximum first, and then an intercept. That's at pi over 2, 0. We have a maximum at 0, 1. Then we have a minimum halfway along at pi, negative 1. Another intercept at 3 pi over 2 and 0. And to finish off, we have another maximum point at 2 pi, 1. The properties for A cosine B times x, B times x. The domain would be all reals. And the range, just like our sine function, is going to oscillate between negative 1 and positive 1 inclusively. The period is going to be 2 pi divided by the b value. And our key points follow the pattern max, intercept, minimum, intercept, and finish off with another maximum value. For example 9, we want to use the 5 key points of the parent function in our first column here. We're going to find a rule if our new function is going to be 1/2 cosine x. So the a value would be a factor on the y coordinate. We would multiply the y coordinate by 1.5. So looking down our table of values, the first point would have 0, 1.5. Pi over 2 would still be at 0. When we get to pi, we're going to have negative 1.5. 3 pi over 2 would still have the same intercept. And then at 2 pi, we have 1.5. So we've got a vertical stretch of 1.5. So 0, 1.5, and 2 pi 1.5, and at pi negative 1.5, with our intercepts being 1/4 of the way on each side. So one complete cycle of the translated graph, 1.5 cosine x. Another one to try, for example 10, we want to use the 5 key points from the parent function. You can tell that the rule is going to have a factor of 2 because we have an argument here, 1/2 x, so we've got a factor on the x of 2. And then we have -2 in the front for the a value, so that's going to change our y by -2 times the y. So completing the table of our new function, we're going to have pi 0, 2 pi, and 2, 3 pi, and 0, and then 4 pi, and -2. So this graph is going to get really stretched out. 0, -2, pi 0, 2 pi 2, 3 pi 0, and 4 pi. So that's our translated or transformed parent function. Describe that transformation. Seems like there was a reflection across the x-axis. That's what the a value of -2 did. We had a vertical dilation by a factor of 2. We had a horizontal dilation, which was a stretch in this case, or you could say horizontal translation by a factor of 2. That's what the 1/2 x did. We could say we know the amplitude is 2, and the period is 4 pi. The midline stayed at y equals 0. Example 11. One last example. We've got y equals 3 cosine x minus 2. So the rule is, in this case, do nothing to the x, multiply the y by 3, and then translate it 2 units down. So the first point stays the same. Pi over 2 is going to get shifted 2 units down. Pi, we're going to be at -5. 3 pi over 2 will be back at -2. And then 2 pi will end up at 1. So our midline, let's draw in that midline. Midline would be at -2. That's this value here, our midline. And sketching the curve 0, 1, pi over 2, -2, pi -5, 3 pi over 2, -2, and 2 pi 1. So we've got a maximum, an intercept, a minimum, an intercept, and a maximum for one complete cycle. Describe that transformation to finish this example off is a vertical dilation, and that factor is 3. We have a vertical translation that's going to send us 2 units down. That moves the midline, so the midline is at y equals -2. The amplitude is the absolute value of a, which is 3. What else do we know? The period stayed the same as the parent, 2 pi. So these basic graphs with their transformations are relatively simple. You just have to be careful sketching them and pacing them out. Join me tomorrow for lesson 3.5.